Hello everyone, my name is Mihail MATEEV. I am Chief Assistant Professor at University on Architecture, Civil Engineering and Geodesy in Sofia, Bulgaria. My research is focused on image analysis and especially how is possible using the latest LLM models and especially OpenAI GPT to have effective image analysis that can be included in different real-life solutions and how we can have also optimal performance and cost optimization using AI as a service and especially OpenAI. This short presentation explains the main details related to research. We will go into introduction, what exactly is the case that we are solving. Also, we will go a little deeper into theoretical and technical framework. We will have more explanation about the exact research setup, and of course, will be discussed results and directions for future research plans. Let's now make short introduction on the use case. Image analysis is related to different technologies like artificial intelligence, computer vision, LLM, data analytics, Internet of Things, mixed reality, and digital twins. The goal of this research is to analyze how the latest multimodal large language models like GPT-4 Turbo with Vision and GPT-4o can interpret images and provide text-based answers to queries related to specific image. Implementing of OpenAI in different solutions is related also to understanding how can interact with these large language models. And it is good also to know into details about modes supported from API of these models. Conversational mode and completion mode. Conversational mode is when we have chat-based conversation. Completion mode is when we have fully description of one case, and after that we have one request with all metadata, and we are expecting answer of this request in one response. Most of the latest LLMs are chat completion based. That means they support both modes, completion mode and conversational mode. On this diagram, you can see how different OpenAI models and other AI technologies are related to different types of data analytics. We will consider in the research also using of standard AI-related technologies like computer vision for specific purposes and mostly for cost and performance optimization. Optimization of image analysis has two directions, improving the preciseness and performance optimization. Usually performance improvement has several different stages. First is related to prompt engineering and how we construct the requests against AI API. After that is considered reusing of already implemented requests if we collect this request using so-named RAG or Retrieval Augmented Generation. And after that, it is also possible to have fine-tuning of the model. That means we are able to update some parts of the model, not the whole model, on reasonable cost with information which already we have in our database. Usually this information is collected with RAG technologies. Now let's discuss a little more about technologies and concepts that are used in the research. One of the main concepts used in the research is separation of concerns, where we are having several different agents to solve different tasks in parallel mode, and also to have agents solving one big case based on solving of subcases. Usually in such kind of implementations, we have the composition of the complex cases using digital twins. Embeddings and vector search are another essential group of technologies used in LLM optimization and also in image analysis optimization. Embeddings usually can be considered like multi-dimensional vectors, vectors with different numbers representing different parameters in specific content. This concept is very well developed for text and generation of content which is text-based, but for images, there are mostly third-party libraries for such analysis, and this case can be solved also indirectly using multi-model LLMs when we are converting images to text description, and after that continue to work with text content parameters. Actually, both techniques using analysis of the image with custom algorithms or using analysis of the text description of the image are important and useful for optimization of image analysis. Vector search helps to find the closest vectors to a specific one generated after a request against AI. I will try to explain more in details when we have request against OpenAI API for LLM models. We can get for some of models also this semantic description of the content or embeddings, and after that we are able to persist this information into one or another database or search service. After that, it is possible to have logic where in next searches to compare generated embeddings with already generated embeddings from previous searches, and if there are equal vectors, collinear vectors, that means you can reuse the same answer if the angle between vectors, the cosine, is very small. That means we can put in the part of the request also the content that is used from previous research. In this way, we can make our search more precise and simpler. Generation of embeddings is much cheaper operation than generation of the exact answer. RAG, or Retrieval Augmented Generation, makes the whole this process automated. We have several steps. First, we are creating the initial request. After that, the content is received and embeddings are received. Both response and embeddings are persisted in database supporting vector search, and each next request first is compared semantically with context from previous request. That means for each next request, we just generate first embeddings, compare with already created embeddings, and this process that we already discussed is vector search, when we have very similar angle between different embeddings. We can use this information from previous searches to make our next search more effective, more precise, and also cheaper in the context of AI resources. Fine-tuning and pre-trainings are the next phases of optimization, especially related to preciseness. Fine-tuning allows, if we have already generated database with request and response, to add this information via OpenAI API and to be used from OpenAI platform to have partial training of some additions to the main model, which is much cheaper than full pre-training, and to have customized search with much better results on lower price. The standard approach with pre-training requires usually a lot of computer resources. There is process to request pre-training of custom models. This process is related also to more time, more computing resources. Time for training is 2 or more weeks, and the cost of such kind of training is very high. The last phase of optimization is when we have a lot of requests, very high load related to request to OpenAI services, and we can have also reserved capacity. Reserved capacity works in similar way like using of reserved capacity for different cloud services. Doesn't matter which one provider is used. You have commitment to pay for specific dedicated for your organization resources, and if you have a very high load, for example, more than 450 million tokens per day, it is more effective to use this kind of approach for optimization in big scope. This table shows base parameters related to reserve capacity pricing model and units that you can use for this operation. Now we will describe a little more details about the exact research. The experimental research use a specific setup where are used both latest LLMs for GPT models, GPT-4 Turbo with Vision and GPT-4o. There is also usage of Microsoft Azure AI Vision to have optimization of the cost and performance for some simpler tasks like image recognition compared to the price to make this with LLMs. And we have two different configurations using computer vision and not using separate standard computer vision, using only LLMs. We have also in parallel using configurations with GPT-4 Turbo with Vision and GPT-4o. In this slide, you can see the overall schema of the experimental setup. It is a solution using Internet of Things. That means devices can make recordings, images, and videos and send them to the cloud. These images and videos are stored in specific data storage. And with the help of coordination service, OpenAI actually makes analysis on the images with several steps, where on the first step is get the general analysis and description, and after that several next steps clarify specific cases till we have clear answers related to the case that we are considering. Actually, it is a setup that can be used for different solutions in the context of predictive analytics. Let's now discuss findings and results from this research. For input parameters for this experimental setup are used images, 2000, data set from 2000 images, free images from free database for construction in US, steel constructions with some effects of rust. There are used also videos, 10 videos, short videos up to 20 seconds, like short videos from robots when make observation, and analysis is done using Azure AI Vision, and in this case we are using object detection to compare performance. We have also OpenAI with two models, GPT-4 Turbo with Vision and GPT-4o. We are using also retrieval augmented generation using Azure Search and comparison between solution with retrieval augmented generation and without using this approach. You can see experimental results on this table and especially accuracy using all combinations of parameters, two different LLMs with or without computer vision in the context of Azure AI Vision, and using retrieval augmented generation and not using retrieval augmented generation. We will comment results a little later. Visual interpretation of experimental results can be seen in this slide. Results here can be considered easier, mostly in the context of time which is used for different type of analysis for both images and videos. Now let's discuss the experimental results. Conclusions based on the research are the following. We can use for modern image analysis OpenAI, especially ChatGPT-4 Turbo with Vision and GPT-4o. When we empower image analysis with computer vision, it provides very, very small in the scope of possible statistical error improvement of correctness, but there is impact in the context of cost and performance. That means speed to solve a specific case. Also, experimental setup is done using low cost, no cost platform, including mostly Power Platform services and especially Power Automate that gives opportunity engineers and researchers who are not software engineers to implement proof of concept and experimental setup without significant effort. For complex images and videos, there is also a recognizable improvement of the performance optimization when we are using the retrieval augmented generation. When we have complex cases, we can use segregation of concerns and we can have the composition of the complex cases using digital twins to describe the complex cases and to make relations between simple subcases and the main cases. Maintenance cost of solutions that are observed with this kind of image analysis can be decreased. Here is considered 10% optimization. Of course, we need to have much more experimental results to have statistically more stable insights related to real cost optimization in the context of maintenance. But in the scope of research, this is what we have like observation. Future steps of this research are related to several directions. To use generative AI to decompose automatically large images, to test and improve proof of concept using more complex cases from different business domains. We are planning also to improve the prototypes and to have implementations of minimal valuable products in production. Another important direction is to provide a cost-effective framework for image analysis based on AI for complex cases that can be reused from other engineers and researchers. Thank you very much for the attention.